So in SC12, we're going to be investigating resistance. So let's start by taking a look at what resistance is. Okay, so when we build a circuit, we build it out of materials which are conductors. So everything in the circuit is usually a metal, and that's because all conductors are metals, or most conductors are metals. And we say that a conductor has very low resistance. And what that means is that it lets the current, the electricity, flow through it very easily. So the lower the resistance of something, a material, the more easily electricity can run through it, okay? Therefore, if we say something has a high resistance, it means it doesn't let current flow through it very easily. So if I change this bulb here, which was our just normal regular bulb that we've been using, and I change it to, oops, why has that gone up there? I change it to, let's try and put that in again and not have it at a funny angle. Right, stay there. So I'll change it to this type of bulb. You can see now that there's a very, very small amount of light being produced and the current is very, very small. So you can also see this bar along here. So the lower I take this bar, I might actually just increase this a bit just for so we can see things better. Okay, so when I have this at the lowest resistance, what this does is it means that my bulb, if I set the resistance at its lowest, it means that it will let current flow through it nice and easily, okay? If you watch as I increase the resistance of my bulb, you can see that the brightness is decreasing, and you can also see if I take it back again, instead of looking at the brightness, if you now look at the current, you can see the current is getting smaller as well. And one last thing to look at, if you look at the speed of the electrons as I raise the resistance or increase the resistance, you can see that they're slowing down almost to the point where you can barely see them move actually. So resistance is all to do with how easily or how difficult it is for current to get through. So in summary, with resistance, the lower the resistance, the easier current can pass through. The higher the resistance, the harder it is for current to pass through. Okay, so looking at SC12, our aim is to investigate resistance in metals and non-metals, or conductors and insulators. So I'd like you to start by writing in your purpose or aim and then going on to your prediction and hypothesis. So pause here and fill in those, please. Okay, so the next thing we need to do is read through our method and then draw in our diagram. So I'd like you to pause on here and read the method, and then I'll show you how to do the diagram. Okay, so the circuit that you're going to be making is you're going to make one with one cell, an ammeter, a bulb, and a gap. Now, remember, when you draw this out into the diagram box, you need to use the symbols. Those obviously aren't quite the same symbols as we use. And one of the main things to remember is to look up what you should draw at the end of a wire. So these would be considered as terminals. So the end of a wire is the terminal symbol. So you need to look that up, okay? So I would like you to have a go at drawing this as a circuit diagram into the diagram box next to the method, please. So now we're ready to actually start doing the experiment. So if you look at this list here, these are the different things you need to try in the gap, and I'll show you how to do that on the app now. Okay, so you should have everything set up like this from when you drew your diagram anyway, but if not, then just take a moment to set this up. So you have a list of things that you're going to try, and you have to fill in obviously the table as you go. So the first thing on the list is paper, a dollar bill. And it might seem quite random, the things in the list, but they're the things that you can find along the side here. So if you use these arrows to go up and down, you can find the things that you're looking for. So here is a dollar bill, here is some paper, and you're simply going to add it in. Now, I'm not actually going to join this up here because I don't really want you to see what's going to happen. But this is what you would do. You would add this in, try and keep everything nice and straight. And then what you need to look out for is, well, first of all, before you join it up, you need to do a prediction of whether you think the resistance will be high, low, or medium, and you just tick it on the results table. Then you need to actually join it up and then read the ammeter reading and write the ammeter reading in. And then in the last column, you have to write down what the actual resistance was. So it might be the same as your prediction, or it might be different. And again, you just have to tick high, low, or medium resistance. And you might want to leave that until you've seen what the other things are, because it's comparative, isn't it? So you might not know if it's high or low resistance yet. So when you're done, you then need to click on the thing that you put in between your terminals and get rid of it like that. So you just click on it and delete it. And then you go for the next thing. So the next thing in the list is actually just a normal piece of wire. So you could put that in and then do the same thing. Now you can see on the results table that I haven't, so if I get the results table back up, what I haven't done is I haven't written these in every single one for you, because you can just choose one of those and write it in here. So if you try the wire and you think it is high resistance, you would just write high resistance here. You'd write the ammeter reading in here, and then you'd write again, let's say you predicted high resistance, but it was actually medium resistance, you'd write medium resistance here, okay? So it should be really easy to go through each of these on the list here, fill in the table until you've got a full set of results. So if you pause this video here and go and do the experiment. And the last thing then is to fill in the purple section. It should be quite easy by now. We've done this so many times before. So pause and do the purple section. I suggest you pause here and check your answers compared to these perfect ones. There are a few that are a little bit different than normal, so it's worth having a real look through. Okay, so we're going to be doing SE13, which is looking at all the different types of resistor and their uses. So the first thing that you're going to be doing is building this circuit here. One little thing in this photo, it shows this as having one of the resistor bulbs. Can you not use that? Just use the normal bulb. So the first bulb that comes up in the list on the left, the one we've been using the whole time. Don't use this resistance bulb, okay? So you're going to build a series circuit as shown, but instead of having this gap here, you're going to just connect the two wires. And then you're going to use the results of that to fill in the no resistor section here. So you fill in the current when there's no resistor, the diagram, and then the explanation section's already filled in for you, okay? Once you've done that, you're now going to create a gap just like is shown, and you're going to add a resistor in. So on the left hand side where all the different components are, you'll see one that is a resistor. In fact, will I see if I can show it to you? Let me just find it. Okay, so it looks like this, and it's labeled resistor. Okay, so you're going to put that resistor into your circuit, and then you're going to fill out, so you'll put it in this gap here, and then you're going to fill out the resistor section. So you're going to put in the new current, you're going to draw a new diagram with the symbol for a resistor. You'll need to look in your booklet to check the symbol for a resistor, okay? And then you also need to fill in the what does it do and why is it useful section. So I'm not going to tell you that. You need to think about what happens when you add the resistor, and if you're struggling, you can use the glossary to help you. So look up what resistor means in the glossary if you get really stuck, okay? But do try and just work it out from what the experiment shows you first of all right? Once you have done that, if you go back to your method, it says now try varying the resistance by clicking on the resistor to change it into a variable resistor. So some resistors, they're just set at a specific resistance, but some, which are called variable resistors, you can change the resistance. So on the app, very helpfully, you can either have it as just a normal resistor, or you can have it as a variable one. So if you're doing it as a variable one, if you click on it, it will come up with a bar down here. Down at the bottom, just like when I was showing you before on the bulb. So it will come up with a bar at the bottom, and you can just adjust it, slide the slider left or right to change the resistance. Okay, and while you're doing that, what you obviously need to do is think about what's happening as you do that. So you'll fill in the amps at a set resistance. I think I was really specific up here. Yeah, I said at 67 ohms of resistance. That's what I want you to do the ammeter reading for. And then you need to draw the diagram with the correct symbol for a variable resistor. So again, you're going to need to look that up in your booklet to find the correct symbol. And then last of all, you need to think about what does it do, this variable resistor, and again, why is it useful? So how is it different to the normal resistor? How is it useful? And again, if you struggle with working out from what you're actually seeing, which hopefully you won't do, but if you do, again, you can check your glossary to help you out with that as well. Okay, so you're able then to do all of them apart from the light dependent resistor, which I just want you to ignore for now. So if you pause the video, go through this method step by step and just follow it carefully, and you should be able to fill in all three of those. The only one you're leaving is the light dependent resistor. Okay. Okay, so we are doing the last part of SC13, this section here, which is on light dependent resistors. The short name, or the shortened way of saying that, is an LDR, so a light dependent resistor. And we're actually not going to be able to fill in this current section because you won't have an ammeter at home, but don't worry about that because we'll still be able to understand how it works when we fill in this section and the diagram as well. So I would recommend using both of your cells that you have in your bag, and then you can use your bulb, but I think it's actually much easier to understand what's going on if you use your buzzer. So I'd recommend using your buzzer. So you need your two cells and your buzzer, and then I'd recommend obviously that you have the buzzer on this side going to the positive, because it just makes sure that you've got the plus side going to the positive. And then you can put another red wire or a black wire, it doesn't matter. And then the all-important new piece of equipment that we haven't seen, which is a light-dependent resistor. So this is a light-dependent resistor. You can see the symbol for it up here. It's a bit complicated, but if you think about it, a resistor is just this rectangle here, isn't it? And then we have a circle around it, and then we have the two arrows to kind of show light coming in. So if you kind of think about it, it makes sense. Okay, so then I will just plug in this to here, and I will plug the black wire in and then go like that. So at the moment there's obviously nothing coming out. Oh, and this is going to be one of those cases where I haven't got enough hands again. Darn it. Right, I have to go and get Mr. Lally to help. Can you get your lamp, and then can you shine it onto the LDR? Okay, so so you can see, or you can hear, take it away for a second please, you can hear that when we shine light onto it, what it actually does is it lowers the resistance. So it makes the resistance lower, which means that more current can flow through. So if we try shining it closer, will you make it go really close? And then further away, and keep adjusting. Thank you. So you can see, can't you, or you can hear rather, that the further away the light, the less light, the higher the resistance, and therefore we don't get a sound coming out of our buzzer. But as the light gets closer and closer, the resistance gets lower and lower, and our buzzer gets louder and louder. So your job is to try and recreate that yourself, and then you need to try and draw in the diagram, remembering to use all the correct symbols, and then explain what it does, and then we'll talk about why it's useful now. So this works really well for things like we often have maybe lights outside of houses that don't come on until it's dark. They'll be on a light dependent resistor, and lots of sort of burglar based things will be based on how much light there is around, so they won't be on when it's bright and they will be on when it's dark. So there's different light dependent resistors. Some need more light, some need less light, depending on what you want them to do. These ones that we have in school work with lots of light in them. Some they'll work when it's dark. Okay, so have a go at doing those yourself now, and pause the video. Okay, so if you could now please photograph your work for SC13 and upload it to lesson 4 in the electricity module on Shobi, so that I can check it and give you some feedback if necessary. Okay, so on to the last SC of this lesson, which is SC14, which is to be able to draw energy transfer chains for machines that use a battery. And this covers quite a lot of stuff. Well, everything in it we've already done before, so I'm hoping that you will either remember this completely or have some memory of it at least. So the first thing that you need to know about in order to do this is the law of conservation of energy. So you should know this because we did it when we did the energy topic in physics. So what I would like you to do is start by trying to write down the law of conservation of energy onto this post-it note, and just do your best with that. So pause this video and try and write down the law of conservation of energy. Okay, so hopefully you managed to remember the law, and if you forgot it, then it is, of course, energy cannot be created or destroyed. It can only be transferred from one form into another. So we're now going to use that law to draw some energy transfer chains for each of the appliances given in the examples. So all you have to do is look at the different parts of the chain. So the pictures should hopefully be clues, and then you have to write down the energies that are being transferred. So what type of energy is held in a cell? If you are really stuck, then feel free to try and research and find out the answers. Feel free to use your glossary, but I don't want to tell you any of these because I really think you should know these at this point. So first one, you'd write down the type of energy stored in a cell. Then what type of energy does it get turned into once our circuit is working? And then last of all, what type of energy does this should be really obvious, it's what our topic is. So what does it then get transferred into? And at this end stage, it's often transferred into lots of different types. So think of a fan, think of all the energy types that you would have coming from it. If you've forgotten the 9 types of energy, then it might be an idea to quickly just have a look back at your energy booklet. If you can't find it, it is of course on Shobi, and just recall the types of energy. So I'll go through them now as well though. So we have light energy, sound energy, electrical energy, chemical energy, kinetic energy, which is movement energy. I can't remember which ones I've said and which ones I haven't. Thermal energy, nuclear energy. Which ones haven't I got? I can't remember. You'll have to think of any others that you're missing, that we're missing on your own. So Then we're going on to, you'll go on to the next one, which is a toaster. Now I've been a bit, I've cheated a little bit here, and I've pretended that this isn't well, most toasters aren't battery powered. Most of them are plugged into the mains. And the mains electricity comes usually from power stations. Now, a lot of our power stations used to be coal, not so many of them anymore. In fact, they're trying to get rid of them completely in the next few years, but we'll stick with coal, seeing as that traditionally was what most of our power stations were. So again, what type of energy is found in coal? What does it get turned into? And then what does our toaster, what are the useful energies and the waste energies that it's turned into in our toaster? And then you'll go on to this torch, and then that is it. So there's only 3 to do, so this should be super easy, super simple. And if you are totally confident, don't worry about uploading them to Shobi. But if you really struggled with this activity, please feel free to upload them to Shobi so that I can check them and give you some feedback. Okay.